A physicist at Los Alamos has just irradiated everyone in the room. He knows it. He can already do the math on himself, and the answer is about a week. So before anyone can help him, he does something strange. He starts turning the room into a diagram, marking where each colleague was standing, how far each one stood from a small metal sphere on the table, who was shielded by whose body. He is not drawing this to save himself. He's drawing it so doctors can estimate how much invisible radiation each of the others absorbed. The sphere is the demon core, and that sketch, scrawled by a dying man on a laboratory floor, may be the single most useful object in the whole story. You've probably met the demon core before. A plutonium sphere, two dead physicists, a blue flash, a screwdriver. It's a meme now. But almost every retelling stops where the second man dies, as if the story ends with the accident. It doesn't. The strangest thing about the demon core isn't how it killed two people. It's what their deaths recorded. Because in 1946, almost no one on Earth had a well-pinned-down picture of what a specific dose of radiation does to a specific human body, tracked from the exact moment of exposure. This accident produced something unusually rare, a tightly bounded human case file. So we'll move through both accidents quickly, then follow what they left behind. The core itself was almost mundane. A 6-kilogram plutonium sphere the size of a softball, left over after Japan's surrender, originally meant to be the heart of a possible third wartime bomb. On its own, it was subcritical, stable, quiet, safe to stand beside. The danger only appeared when you wrapped it in the right material and asked how close you could push it to a chain reaction. On August 21, 1945, Harry Daghlian was stacking neutron-reflecting bricks around it when he fumbled one directly over the core. For a fraction of a second, the assembly went supercritical. He knocked the brick away with his bare hand and stopped it, but the burst had already passed through him. Daghlian took a clearly lethal dose, often put around 5 sieverts, and died 25 days later, and this is the turn that makes it more than a tragedy. Doctors watched the whole decline on a clock. Hour by hour, they logged the nausea, the falling blood counts, the collapse of his white cells, the timeline of a human being taken apart by radiation from a known source. In 1945, that barely existed. Almost everything science had came from animals or from Hiroshima and Nagasaki survivors whose doses had to be reconstructed afterward from distance, shielding, and location. Daghlian was something colder and rarer, a closely monitored exposure where you actually knew what hit him. This is where it stops being a famous lab accident and becomes a medical detective story. If that's the kind of strange you're here for, you're going to want to stick around. 9 months later, Louis Slotin ran the same kind of experiment, a more dangerous way. The core sat between 2 beryllium half-spheres, excellent neutron reflectors. Safety shims existed to stop the shells ever fully closing. Slotin didn't use them. He held the top hemisphere in one hand and kept the gap open with the blade of a screwdriver, a shortcut he'd done many times. On May 21, 1946, the blade slipped. The shells closed, neutrons flooded back in, and the core went prompt critical. He flipped the top hemisphere onto the floor in under a second and ended it. The exposure was already over. And here's the part almost no retelling lingers on. Slotin knew immediately what he'd done, and then he went to work. He had everyone mark exactly where they'd been standing. He sketched the room, the table, the core, every person's position and distance, because in a criticality burst, position is dose. A foot closer, a colleague's body in the way, a bench between you and the sphere, each one changed how much radiation you absorbed. He had no instrument that could tell him after the fact, so he turned the room itself into the instrument. Think about the problem the doctors faced. The radiation was gone. No wound, no residue you could read off a meter. So investigators reconstructed it two ways, and both are still the backbone of radiation forensics. First, physical dosimetry. Take the geometry from Slotin's map, the known materials, the energy of the burst, and calculate backward to how many neutrons and gamma rays struck each spot. Second, biological dosimetry. Read the dose off the body. When did vomiting start? How fast did the white cell count crash? Each of those is a clock calibrated to dose, the body keeping its own record. Lay the people along that map and you get something no lab would ever be allowed to build on purpose: a dose-response curve drawn in real bodies. Closest of all was Slotin himself. Roughly 1,000 rad, unsurvivable. He died 9 days later, his decline documented in detail. The high anchor of the curve. Just behind him stood Alvin Graves, watching over his shoulder, partly shielded by Slotin's own body. Graves took the largest dose anyone in the room survived. Weeks of severe illness, then recovery. He went back to high-level weapons work and died 19 years later at 55 of heart failure. Was it the dose? Maybe. His father had died of heart failure too. And that uncertainty, the dose, or just life, is the single hardest question this whole dataset raises, and the one it most often can't settle. Farther out, the doses dropped and the timeline stretched from days into decades. Marian Cieslicki, one of the lower dose men, died of leukemia years later. And leukemia is exactly radiation's signature, which is why the follow-up kept circling the same question, which later cancers belonged to that afternoon, and which would have come anyway. At the quiet end of the room sat Raymer Schreiber, a modest dose who lived to 1998, 52 years after the flash. One event, one afternoon, and an arc of human outcomes from 9 days to 52 years. That spread is the data. So why did one terrible afternoon matter so much to science? Because by the standards of radiation accidents, it was unusually legible. Most radiation data is fogged by uncertainty. Doses estimated long after the fact, exposures dribbled out over many sessions. This was close to the opposite. A known source, a geometry mapped on the spot, a precise 0 hour, a mix of neutron and gamma, and a group of men followed by doctors for the rest of their lives, written up in survivor reviews soon after and again decades later in a 1979 report. In the coldest terms, it was a controlled experiment no ethics board would ever approve, run by accident, and then carefully read. And what it taught still sits in the room with you in any hospital. The timeline of acute radiation syndrome, the early sickness, the deceptive lull, the collapse of the blood-forming marrow was charted in cases like these. Serial lymphocyte counts are still used in radiation emergency triage today to help estimate a patient's dose. The rule that if you vomit within the hour you were close to the source, that was paid for here. Now jump 53 years to Tokaimura, Japan, 1999. 3 workers at a fuel plant, mixing uranium by hand to save time, pour too much into a settling tank and tip it past the critical limit. The same blue flash, the same prompt critical burst, and the same forensic ritual the Demon Corps forced into being. Investigators reconstructing the geometry of the room while doctors read the dose off the workers' bodies. now even counting the broken chromosomes in their blood to estimate how much radiation passed through. One worker, Hisashi Aochi, had absorbed one of the highest doses ever recorded in a human. Doctors kept him alive for 83 days and ran straight into the wall. Slotin's chalk marks first exposed in 1946. You can measure a dose with astonishing precision and still not be able to undo it. The case file that opened on a Los Alamos floor was still being written in a Japanese hospital half a century later. We should be honest about what that sentence means. Nobody should become a data point this way. Daghlian, dead at 24. Slotin, dead at 35. Men who carried doses and unanswerable questions in their bodies for the rest of their lives, never quite knowing whether the cancer or the bad heart was the room's doing or just their share of ordinary bad luck. The knowledge was real, and it has helped people since, but it was bought in advance in people who mostly just came to work that day. The famous part of the Demon Core story lasts less than a second. A slip, a flash, a room gone quiet. The useful part lasts decades. A floor plan, a set of reconstructed doses, a handful of bodies followed across their whole lives. Not a perfect record. Nothing about a radiation accident ever is. But one of the clearest accidental case files anyone in that field ever had. And so the next time a doctor estimates a radiation dose off a falling blood count or back calculates an exposure from the layout of a room, they're working at a distance of decades from the same idea a dying man had on the floor, that if he had to become an experiment, he'd at least be a careful one. Until next time, keep asking what the wreckage is trying to teach you.